If you want success, remember this: the world will not believe in you until you prove yourself. People will doubt you, they'll criticize you, but your job is not to convince them with words. Your job is to convince them with results. Think about Elon Musk, who faced ridicule when he spoke about electric cars on space travel. Many experts said Tesla and SpaceX would fail. But today, both companies are pioneers in their industries. Why? Because he never gave up and he proved himself through results. And this is how you have to make it a habit. And in today's video, we are going to discuss about chi-square test for independence of attributes. So in my earlier video, I have explained you each and every point, and here in today's video also. So here literally an attribute means a quality or a character. Examples of attributes are drinking, smoking, blindness, honesty, beauty, etc. See, we are going to use a two-way table. So in this, we are going to use a two-way table. And the first thing is the null hypothesis. We have to find out H naught. So we assume that the two attributes are independent. And in alternate hypothesis, we assume that the two attributes are not independent. So here is an expected frequency formula. For any expected frequency, we have to make a row total into column total by grand total. I'll explain through a problem here. And the next one is the test statistics. Chi-square is equal to sigma OI minus EI whole square by EI. And the next one is, so we have to find the degrees of freedom, the number of rows minus 1 into number of columns minus 1. So this will be the degrees of freedom, and in the table we are going to check the table value. So if through this, if you calculate chi-square value, if the calculated value is less than the table value, then we are going to accept H naught. If the calculated value is less than greater than the tabular value, we are going to reject H naught. And this is the procedure here. And 1-2 examples are already solved. And in today's video, I'm going to explain from the third example. So here is example 3. Given the following contingency table for hair color and eye color, find the values of chi-square. Is there good association between the two? So here hair color is given, eye color is given. So hair color fair, brown, black, and eye colors are blue, grey and brown. So this will be the grand total. So this will be the total. So every time, so 15 plus 5 plus 20, the value here is 40. Addition, 20 plus 10 plus 20, this is 50, and 25 plus 10 plus 20 is 60. And here also the column total here, if you observe here, this will be 15 plus 20 plus 25, the value here is 60. 5 plus 10 plus 15, the value here is 30. 20 plus 20 plus 20, the value here is 60. So this will be the grand total. 40 plus 50 plus 60 is 150. And here also 60 plus 30 plus 60 is 150. So first of all, we have to make the column total, row total, and next one is a grand total. And now we are going to find out the expected frequencies. So these are all the column totals. So column totals, and these are all the row totals, and this is the grand total. And now we are going to find out the expected frequencies. For 15, see here, the column total here is 60 and the row total here is 40. Now 60 into 40 divided by 150. 60 into 40 divided by 150 is 16 here. And the next one, for this value 20. So here the column total is 60 and the row total here is 50. That is a 60 into 50 divided by the grand total 150. The value here is 20. And the next one, for this, the column total is 60 into row total is again 60 divided by 150. 60 into 60 by 150, the value here is 24. And for the second column here, goes straightly with the column total, that is 30. And the row total here is 40. 30 into 40 divided by 150. 30 into 40 divided by 150, the value here is 8. And for this position, see here, this is 30 and this total here is 50. 30 into 50 divided by 150, the value here is 10. So for this one, 30 into 60 divided by 150, the value here is 12. So for this position, see here, the column total is 60 and the row total here is 40. 60 into 40 divided by 150. The value here is 16. For 20, see here, 60 into 50 divided by 150, the value here is 20. And 60 into 60 divided by 150, the value here is 24. And next one, we have to make the total for all the expected frequency, that is 16 plus 8 plus 16, which is equal to 40, and 20 plus 10 plus 20, the value here is 50, 24 plus 12 plus 24 is 60. And next one, column total, 16 plus 20 plus 24, 60, 8 plus 10 plus 12, 30, and 16 plus 20 plus 24, the value here is 60. And now this will be the grand total, 60 plus 30 plus 60, 150, and here 40 plus 50 plus 60 is again 150. So observed values are ready and expected values are also ready. And now we are going to calculate the value for chi-square. And this is the table for calculating the chi-square. The first one are the observed values. So from where we are getting the observed values, see here, 5, 15, 5, 20, 20, 10, 20, 25, 15, 20. So we have to place it in the first column. Clear? Unexpected values. So this will be 16, 8, 16, 20, 10, 20, 24, 12 and 24. So in the second column. And now we have to make a subtraction and make a square. That is 15 minus 16 minus 1 whole square is 1. 5 minus 8 minus 3 whole square is 9. 20 minus 16, 4 square 16. 20 minus 20, 0 square. 10 minus 10, 0, square is 0, 20 minus 20, 0, 0 square is 0, and 25 minus 24, 1 square is 1, 15 minus 12, 3, 3 square is 9, and 20 minus 24, this is minus 4 whole square is 16. And now this is the column where we are going to get the answer. That is OI minus EI whole square by EI. So this is one column, and so we have to make an addition. 1 by 16 is this one, 9 by 8 is this one, 16 by 16 1, 0 by 20 0, and 0 by 10 is 0, and next one 0 by 20 0, and 1 by 24 is 0 0.042, and 9 by 12 is this one, 16 by 24 is this one. And now we have to make a total for it, that is 3.6458. So this is the total here, and therefore after making a sigma chi-square value is equal to sigma OI minus EA whole square by EA, the value is 3.6458. Now we are going to find out the degrees of freedom here. So from the textbook we got 3.6458. So this is straightly from the textbook, I have explained you. So this is 3.6458. It is the calculated value. Now we have to find out the degrees of freedom. So the degrees of freedom means the number of rows minus 1 into number of columns minus 1. So how many rows we have? 3 rows we have. So here the rows are, see, 1, 2, 3 rows and 1, 2, 3 columns. So 3 minus 1 into 3 minus 1. 2 into 2, this is 4. At 4 degrees of freedom at 5% level of significance. So this is the chi-square table at 4 degrees of freedom at 0.05. This is 9.488. So here the value here is from the table. So the table value will be on the back side of the textbook, that is 9.488. Now the calculated value is 3.6. The calculated value is 3.6 and the tabular value is 9.488. So clearly the calculated value is less than the tabular value, and now we are going to accept the null hypothesis H0. If it is less than, we can accept, and therefore the hair color and the eye color are independent. The hair color and eye color are not associated, and this is the final conclusion. So hope you all guys understand how to find out. And the next question here is the fourth question here. Two researchers adopted different sampling techniques while investigating some group of students to find the number of students falling into the different intelligence level. The results are as follows. See here, these are the results. See here, the results are researchers. So below average, above average. So here this is below average, above average, genius average. So these are all the values given from the textbook itself. So these are x values and these are the y values. And see, 86 is 60, 40, 44 and 10. So immediately we have to make an addition. Row total here is 200 and 40 plus 33 plus 25 plus 2 is 100. And next one, column total here is 126. Here 60 plus 33 is 93 and 44 plus 25 is 69 and 10 plus 2 is 12, and this will be the grand total. The 300 is the grand total. See, remember. So would you say that the sampling technique adopted by the two researchers are significantly different? Given 5% level at chi-square for the 2 degrees and 3 degrees of freedom are 5.991 and 7.82 respectively. Here the degrees of freedom value is also given. So in this first one is a null hypothesis. There is no significant difference between the two researchers. The table for the expected frequency. So here is the expected frequency for 86 position. So we have to take the column total 126 into, this is 200 divided by grand total 300. See here, first one is 126. So see here, these are the totals here. See, this is 126 into 200 divided by 300. The value is 84. And the next one for 60, this is 93 into 200 divided by 300. The value is a 62. And for 44, see here, the column total is 69 and the row total is 200 divided by the grand total 300. 69 into 200 by 300, the value here is 46. And for next thing here is for 10 position. So here the column total is 12 and the row total here is 200 divided by grand total, that is 300. The value here is 8. And for 40, see here, the column total is 126 and the row total here is 10. 126 into 100 divided by 300. 126 into 100 divided by 100 is 42. And the next thing here for this 33, the column total here is 93 and the row total here is 100. 93 into 100 divided by grand total 300, that is 31. And the next thing here for 25, see here for 25 the column total is 69 and the row total here is 100. 69 into 100 divided by grand total, the value here is 23. And the next thing here is for 12. So for 2, the column total here is 12 and the row total here is 100. 12 into 100 divided by 300, the value here is 4. And see, we have to make a grand total, that is 84 plus 62 plus 46 plus 8. The value here is 200 and 42 plus 31 plus 23 plus 4 is 100. And next one is the column total, 62 plus 31, 93 and 46 plus 23 is 69. 8 plus 4 is 12. And see here, this will be the grand total. And next one for calculating the chi-square value. So these are all the observed frequencies, expected frequencies. Observed frequencies we'll be getting from the table, that is 86, 60, 44, 10, 40, 33, 25, 2. So here we have to place it in the first column, observed frequencies, and the expected values are 84, 62, 46, 8, 42, 31, 23, 4. So we have to place it in the column 2. And now we have to make a subtraction and we have to make a square. 86 minus 84, 2. 2 square is 4. 60 minus 62, this is minus 2 square is 4. 44 minus 46, that is minus 2 whole square is 4. So we have to fill this column like this. And next one, this column is nothing but OI minus EI whole square divided by EI. So where is EI? So this is the expected frequency EI. So 4 divided by 84 value is this one, 4 divided by 62 value is this one, 4 divided by 46 and 4 divided by 8 value is this one, 4 divided by 42, and we have to fill this column and we have to make an addition. So here this is sigma summation of sigma OI minus EI whole square by EI, and this is nothing but, so here, so this value is nothing but the chi-square value is equal to sigma OI minus EI whole square by EI, which is equal to 2.0971. So this will be the calculated value. And now we have to go with the degrees of freedom. So here 2 minus 1 into 4 minus 1. See here, rows, number of rows are xy. So this is 1 row and this is 2 row. So 2 rows. And how many columns are there? 1, 2, 3, 4. 4 columns are there. So here number of rows minus 1 into number of columns minus 1, degrees of freedom. So 2 minus 1 and 4 minus 1, which is equal to 3. At 3 degrees of freedom at 5% level. See here, this is the chi-square table test, and degrees of freedom at 3 at 5% level, this is a 7.815. Clear? At 7.815. The value here is a 7.82. So this is the calculated value and this is the tabular value. Clearly the calculated value is less than the tabular value, and now we are going to accept the null hypothesis H naught, and there is no significant difference between the two researchers. And this is the final conclusion, and this is how we have to solve one after the other. And the next one here is the fifth question here, and this is also important. 4 methods are under development for making discs of a superconducting material. 50 discs are made by each method and they are checked for superconductivity when cooled with liquid. See here the first method, second method, third method and fourth method. So these are all the methods. First method, second method, third method, and these are all the superconductors and these are all the failures. The first thing is test the significant difference between the proportions of the superconductors at 0.05 level of significance. Every time we have to go with the following points. First one is the null hypothesis. So here is the solution. So the null hypothesis will be, see here, the null hypothesis will be P1 equal to P2 equal to P3 equal to P4. So each and every methods are equal, alternate hypothesis. So they are not equal level of significance at 0.05 level of significance. And here is the computation. So this is the table given. So first of all, we have to make a row addition and total addition. Row addition and column addition. See here, 31 plus 19. The value here is 50. See here, this is 50. 42 plus 8. The value here is 50. 22 plus 28. The value here is 50. 25 plus 25. The value here is, see here, 50. And next one, row total, 31 plus 42 plus 22 plus 25, the value here is 120. 19 plus 8 plus 28 plus 25, the value here is 80. And see, this will be the grand total. 120 plus 80, the value here is 200. And next one, 50 plus 50 plus 50 plus 50, 200. And now how to find out these expected frequencies? So here is very simple. First one is row total into column total divided by grand total. In first position, this is 50 into 120 divided by 200. The value here is 30. So for this 42, see here the column total is 50 and row total is 120 divided by 200. The value here is 30. So for this the column total is 50 and row total is 120. This is 50 into 120 divided by 200. The value is 30. For 25, the column total is 50 and row total is 120 divided by 200. The value here is 30. And for this 19 also, the column total is 50 into row total 80 divided by 200. 50 into 80 divided by 200, the value here is 20. For 8 position, column total, that is 50 into 80 divided by 200, the value here is 20. And next one for this 50 into 80 divided by 200, value is 20. So for this the column total 50 into 80 divided by 200, the value here is 20. And now we have to make the addition for this 30 plus 30 plus 30 plus 30, 120. 20 plus 20 plus 20 plus 20, 80. And here the column total here is 30 plus 20, 50. 30 plus 20, 50, 30 plus 20, 50 and 30 plus 20, 50. And here is the grand total here, 200 again. So we got 200. Clear? And the next one here, so all these are observed values and these are all the expected values. So for finding the chi-square value, see first of all we have to write all the observed values. So observed values are from the table, that is 31, 42, 22, 25, 19, 8, 28, 25 in the first column. Place it in the first column. These are all the expected values. So these are 30, 30, 30, 30, 20, 20, 20, 20. So we have to place it in the second column, and now so we have to make a subtraction and square it. OI minus EI whole square. So this is 31 minus 30. 1 whole square is 1. 42 minus 30, 12 square is 144, 22 minus 30. See here, this is will be minus 8 whole square is 64, 25 minus 30, minus 5 whole square is 25. So we have to fill this column like this, and this column is so important. So this column divided by EI, expected frequency, that is 1 divided by 30. And next one, 144 divided by 30, 64 divided by 30, 25 divided by 30, 1 divided by 20, and 144 divided by 20, 64 divided by 20, and 25 divided by 20. So you can use your calci. So we will be getting the answers in the decimals, and the total decimal here is, this one is 19.5. See, clear? 19.5. So we got the calculated value as 19.5. And see how many rows are there and how many columns are there. Let me show you. See here, as per the question given, so there are 2 rows here, 1 and 2. And how many columns are there? 1, 2, 3, 4. 2 rows and 4 columns here. Remember. See here, now for chi-square, the degrees of freedom here is the number of rows minus 1. So the number of rows are only 2 and number of columns are 4 minus 2. So 2 minus 1 is 1 and 4 minus 1 is 3. So we have 3 degrees of freedom at 5% level of significance. So here is the table. So here is the chi-square table here at 3 degrees of freedom at 5% level. See here, this is 7.815. So here the value here is 7.815. Sometimes we'll be getting a small mistakes even in the textbooks. Please go through the procedure. That is a 7.815. So this is the calculated value 19.5. Clearly, since the calculated value is greater than the tabular value, so we reject the null hypothesis H naught. And therefore, what is the final conclusion here? So here there is a significant. So there is a significant difference between the proportions, and this is how we have to solve. So this is the procedure, and this is the most important question, repeatedly asked questions. Chi-square test of for independence of attributes is a damn important question. Please, if you like, you know what to do. Raise your thumb, pass it on to your friends, and subscribe to this channel and stay connected.